Hi, everybody, and welcome to CS532. My name is Bruce. I really like operating systems. I'm going to be honest. They make it easy for us to use all sorts of computer hardware, everything from CPUs to disk drives to SSDs, networks, and uh, mouse and a trackpad and a keyboard, everything. It just coordinates all of that stuff for us. I think it's just amazing that they can do that. They allow us to use multiple pieces of hardware at the same time. You can have multiple processes running on the system. You can have multiple users, multiple different connections to different websites open. All those things are facilitated by the operating system. I just love that. They protect different processes from one another. They make sure they don't kill each other or hurt each other. And same thing with users. You have multiple people using a computer. The operating system manages all of that and protects it and makes sure that the right people have the right access to the right things. I love them because we have such a variety of operating systems. And I love it that people treat them as such a personal thing. People get in all sorts of crazy arguments about, Macs versus PCs versus Linux versus different kinds of Linux and all this stuff. And that's just on, sort of desktop hardware and laptop hardware. Then you get into mobile operating systems for mobile devices and things, people get even crazier about that sort of thing. I just love that personal nature and that people of all have a care about what operating system they're using. I think it's great. In this class, we're going to get down to the details, and we're going to start with CPU. And if you look at what a CPU does, it's very simple and basic. CPU fetches the next instruction in memory, decodes that instruction, fetches the operands for the instruction as needed, depends on the instruction. There's lots of different kinds of instructions for an instruction set architecture like Intel. Hundreds of different ones, but for many of them, they need to fetch operands from memory, execute that instruction, and store the result, and then go back and do it all over again. This is basically what a CPU does, but thankfully, we don't have to program things at that level. The main job of the operating system is to enable programs to do these steps billions of times per second, easily, efficiently, and safely. So that's the basics of what an operating system does with a CPU, but there's so much more to it. As I said before, operating systems allow many programs to use hardware at the same time. They give every program the illusion of having the hardware all to themselves. They manage those resources efficiently and effectively, and they protect programs from one another. We're going to talk about all of those kind of aspects of operating systems in these videos. They enforce security objectives. Security is not something that we're going to talk so much about in this class. We're not going to get into security and networks all that much, although maybe in the future we'll have some videos on those topics as well. A basic, major objective for an operating system is to make it easy to use the computer in all of its complicated complexities. You want to still, at the end of the day, make it easier for programmers to get their job done and to use the computer. And for users to use the computer as well. And as I said before, a big part of the operating system's job is to allow us to interact with external devices, especially storage and networks. Operating system does all that through a general technique that we call virtualization. And if you read the book, when you read the book, I should say, you find they talk a lot about virtualization, and virtualizing the CPU is the first part of the book. Each program that runs on the computer operates as if it's running alone. And we call these processes virtual CPUs, and a process is an instance of a program that's running by itself. It also virtualizes things in memory by giving programs or processes virtual memory, and that is the illusion that the process has its very own memory address space, independent of all other programs. It does all these things through a system called API. Operating systems have a special set of functions that you can call to get access to operating system level privileges and functionality. Call that the operating system call API. And then finally, the operating system automatically manages all the resources so that they're shared effectively and fairly and according to whatever objectives the operating system or the system administrator might have.